Hello, hello. Can you hear me, class?
Yes, sir.
Okay. For a while, we'll start our discussion
Silent
like
sir.
9:15. It's okay. Ati man kadjut. Okay. Patuloy na lang natin yung ating talakayan.
Ako ng context.
Okay, let's start our class. So, good morning, everyone.
Morning, sir.
Good
Okay, good
morning,
morning,
sir.
good morning.
Morning, sir.
Good morning.
Morning, sir. Morning, sir.
Okay, we'll continue our discussion about basic electricity. So, last time, no, we discussed about the different types of electricity. We also discussed about the circuits, diba? So, what are the two circuits?
Series circuit and total circuit.
Okay, we have the series and parallel circuits. Okay, so how about the type? How about the kind of circuits? How about the types of circuits? The kinds of circuits. What are those? So we have kernel. Okay, so let's continue our discussion. Let's focus here on the Ohm's losses. Uh, we did a little one, diba? Let's say we have a trouble. Okay, understanding how did we come up with an answer of uh, a 30 ohms. Okay, let's go back to this to this problem. So uh, when you use the parallel circuits in formula class, especially if you're talking about the total resistance, so all we need to do is since naka-fraction form maguni siya tanan. Okay, especially when you're calculating for the total resistance. Uh, Always gonna remember that the very gonna bitang the obvious clue, okay, or the technique that we can use to identify the correct answer in looking for the answer sa total resistance is that you have to look for uh, greater common factor niya. Okay? So, sa greater common factor niya when it comes to calculating the total resistance sa parallel circuits. So, this problem here sa kanisang about sa R1 which is 50 ohms and R2 which is 75 ohms. The reason why we got the answer of 30 ohms is that atong gikuha ang iyahang GCF. Okay? Iyahang GCF. So sa GCF sa 50 o sa 75. So the answer there is 150. Okay? So the 150 there is the GCF of the 50 and the 75. So how did we get the 150? So for us to get the 30 ohms, katong 150 dito, if we go back to the basic mathematics ng good, uh, we will be dividing the 150, which is the GCF, to the 50 and 75. Diba? That is what happens sa That is something that we do when we're looking for an answer, especially sa mathematics. Okay? Okay. Ako sa share screen para madali na rin. Refreshment na sa tanong about this one. Please tell me kung ma-appear na sa inyo ang board. Okay. Visible siya sa inyo, ha?
Yes, sir.
Yes, sir.
So, why 150? Kani siya. Why 150? Because we're looking for the GCF. Actually, kung atong pitong kaon ni ang last common denominator sa 50 o sa 75, pila itong makuha? Kung mag-LCD ta dani. Anyone has an idea? Pilang LCD sa quad? 50 o 75? Sa review lang. Start of review lang. Pila ka?
5, sir.
Ang LCD lang sa 50 or 75. This is the GCF, ha. It means that on the total resistance, looking for the total resistance function, we need to look for the GCF for every for every kalibitang number given. So 150. Now, if we will be divide to get the 30 ohms, okay, we need to justify this one. Okay, medyo complication. So we will be dividing the 150 to the 50 and 75. So this will what will happen? So 150 divided by 50, pila.
3.
3.
So we'll be replacing this one by 3. Then 150 divided by 75.
2.
So we have 2. No? So after this one, so may tapo tayo na. We'll be adding, di ba? So we have 5 divided by 150. Remember, 90, naay ka ng over 1 bito dani natay kung 1 sa ibabaw. So if we will be dividing 1 divided by 5 divided by 150, pila itong makuha?
30.
Okay. Was it 30? Nakuha ang 30?
Yes, sir.
Okay. How about the others? Nakakuha ang the answer?
Yes, sir.
Yes,
Okay.
sir.
Okay. Very good. So that is how we calculate the total resistance when it comes to the parallel circuits. Sorry for this one. Okay, let's continue our discussion. Okay. Any question about calculating the parallel circuit? And so far for now, let's move on to the next one. So we're done discussing about the quantum class, sorry. We're done discussing about the series parallel, no? this one, the combination of the series and parallel circuits. We're done
Mana,
discussing
sir?
it.
Wala, sir.
Okay, so paano, it's easy if you know what to do. Okay, so we have steps involved in solving the circuits. So first thing you need to do is to look for the parallel circuits in the given illustration, and then try to merge. Okay, get the total resistance of those parallel circuits, and then after getting the total resistance of the two circuits, uh, you solve the whole process using the series circuits na dayon. But remember ha, dili na siya gakuan lang class, dili na siya isa lang ka series circuits usahay ang ginahatag, or isa lang ka parallel circuits, I'm sorry, isa lang ka parallel circuits ang ka-involved when it comes to the relationship of the combination between series and parallel. Sometimes more than that, no? So, the more parallel circuit is involved sa dani nga topic, the more makataas ang iyahang solution. But as long as you know how to calculate, okay, then you will get the correct answer. Okay, now let's talk about potential difference. Okay. So what is potential difference and how is it related to the Coulomb's law? Okay. Do you know what's Coulomb's law? Diba? We've been hearing a lot of about we've been hearing the Coulomb's law, okay, and how is it related to the electricity, and what is the impact of the Coulomb's law when it comes to studying the basic function of or the formula when it comes to electricity. Dili ako ang kwan Christian, dili ako ang host. It's Philip. Philip, ang set ko si Valin. Kaya sa about potential difference. So what is the potential difference? Wait lang klasa kay nagbuwang na po akong laptop. Okay, anyone na idea about potential difference? Or unsay potential difference?
Ako, sir.
Okay, that's just Steve.
Potential difference is the difference in the amount of energy that charge carriers have between 2 points in a circuit.
Okay. So potential difference is about the charges at the 2 points of its circuits. Is that what you meant? For a while pa sabi, nagdrama na po ako laptop. Nagdrama siya drama sa yung live. Thank you so much for that, Justin. Okay, after potential difference, your answer is correct, no? A charged particle that has a potential energy due to its position relative to another charge or object. So we call it electric potential energy. So why do you think it is connected to the potential energy? Since potential energy is all about stored energy, it means that it could be possible that in every material, each of those material has this opposite charges that will allow no the connections or any electrical charges to flow through it as long as it's kind of it's not repulsive. Okay, for example, the positive particle has potential energy on this a position. Okay, let's take for example this is another uh, object. Okay, and the other object will be the opposite, okay, of the first object. The second object has a negative charge. So once the particle moves to the B, all the potential energy now will become a kinetic energy, because the particles now will now be moving towards the opposite charge. Okay, so the negative plate has a low potential and the positive plate has the high potential. So if our socket is made up of negative charge particles and we have this, let's say, we will be connecting something dito sa socket na positively charged. The result will be, okay, the result will be, uh, some of the positive charges now will be transferred dito sa socket na nga na negative charge. Okay? So, what do you call it one? Kasi tawag na to dahil sa katong socket. The socket now will be the conductor. Okay? It means it will now allow the numbers of positive charges to flow through the negative charge na socket. So since lesser man ang number of negative charge on the socket, so the solution now there is that more of the positive charge will now be flowing into the negative. So walay insulation may tabo. Okay? Unless no uh, the socket has more on the positive rather than the negative, then there might be possibility that most of the negative charge will not flow through the socket. So sa high dili mo function. So for us to identify more about the use of the potential difference in the basic electricity, we will define that one by using the mathematical expression. So the potential, which is uh, represented by the symbol capital V, is defined as the potential energy per charge. So we have V is equals to the potential energy divided by the electrical charge. So PE divided by Q. So what will be the unit for this one? The unit of the potential difference will be a volt. Okay, so J per C. Okay, because the unit for the electrical charge is in Coulomb. So we have joules per Coulomb or volts. Okay, note that only changes in P are measurable, and that is what you meant by potential difference. So the change, since no sa energy magod is we cannot just dispose any energy in a given situation. So the idea there is that all of the energy that will be coming from a material that has a potential energy can only be transformed into kinetic once those both charges will flow in a medium. So in a given situation, for example, if we have this voltage, okay, the voltage has this positive and negative charges or particles, and then it will flow through the wires. And each of the wires now will have different charges. So some of the sockets will have okay, some of the punta ta lugar ha, bansakana, no? Or some of the switch will have a negative charge and some of them will have the positive charge. So either charges will flow through the wire will have at least no a potential to have a reaction because they will not observe a repulsion nga kwan na there will be no repulsion. Okay? Walay ma-repel ng mga charges because the wires will have different charges. And then the switches as well have different charges. So as long as they're opposite, we will always achieve the positive result. Okay? So there will be changes. So voltage is a measure of how energy an electric charge can acquire. So if we will be calculating the potential energy of a certain material that has a voltage, all we need to do is just to derive a formula out from the formula sa potential difference. So how did we get the change of PE is equals to the charge multiplied to the voltage? So simple lang, no? Ato lang siyang derive coming from the V is equals to PE divided by the by the Q. Since charge and energy is the ability to do work, it is also a measure of how much work is done by an object. So again, if we go back to the general physics one, the relationship between the force, the work, and the energy and the power is directly proportional. Okay, they're all directly proportional. It means one can stand without the presence of the other one. So since potential energies can also be compared to the work, so we can also change the symbol of the PE as a work. Okay, so we have work is equals to the charge, electrical charge, multiplied to the voltage. So the potential difference can be measured by using the voltmeter. It's the same as the voltage as well. Instrument used to measure the voltage between 2 points. So, nakita na ba siguro mo pa siguro no voltmeter no katong na ay red og na ay black. Mura ipit-ipit. Kita na mo na.
Yes, sir.
Yes, sir.
Di ba mo lang ginagamit most of sa mga especially those mga electrical men, mga electric men. So, usually ginagamit ko na siya sa palmangga ayo sa cellphone no, to test kung kana ba siya nga material is still able to at least no kana bitang makakon pa gyapon siya makadetect gyapon siya mga voltage because if a material cannot detect any voltage anymore if the voltmeter cannot detect any reaction anymore from a certain material it means that wala na siya charges. Okay, sige, let's have this example. An electron in the picture tube of a TV is accelerated from the rest to a potential difference of a positive 5,000 volts. The question now is what is the change in the potential energy and what is the electron speed and how much work is done. Okay. And then also the example number 2. The terminals of a 12 voltage battery differ in the potential by 12 voltage as well. Suppose that the wire is connected between the positive and negative terminal and a 3.0 a 3.0 column of charge travels between them. How much work is done? Okay. And example number 3, we have electron loses at 3.45 times 10 to the power of negative 16 joules of potential energy as it moves from a plate A to B in a computer monitor. What is the voltage between the plates and which plate has the highest potential? Okay, so let's have number 1. Okay. What will be the change in the potential energy if we have a voltage of positive 5,000 volts? Okay, and what is the electric speed? Okay, so we're talking about the charges. So what could be the answer and how much work is done? So let's try to answer this one later. Let's talk about electric field check. Okay, just we'll be answering this one because natay ba discover sa Coulomb's law later. The units of electric field. So the units of electric field can either be a Newton per coulomb or a volts per meter. Okay, and then let's try to quantify it. Then a small energy unit, okay? The joules is traditional unit for the energy, but with every small particle, this unit appears a very large. Okay, so sometimes we come up with an answer about kilojoules, but again, the unit for the energy, or even on the so work or power, the presence of the joules is there. And the smaller unit of energy is used for this called the electron volt or EV. So if you have a smaller energy, for example, we have a sample value for a small unit of energy, then we use the electron volt, or a small amount, of energy is present, and we call it electron volt, since volt is a potential energy as well. So before doing a problem, always change the EV to J. So simple reminder. So remember that a 1 electron volt has a 1.6 times 10 to the power of 19 joules charge na siya. So that is the value, no, of the potential, or the what, the, let's say, yahabitang kwan, amount, okay, yang amount. Okay, let's try to answer the first problem kanina, class. Let's go back to this one. How can we get the change in PE? No? Okay, ato let's move on to columns na lang sa before we answer those sample problems. Okay, ato lang sa itong tigumon para solving na lang ta later on sa next discussion. Okay, let's talk about columns now. Okay, because it's very important to discuss this part. Let's talk about columns law. Now, because we're talking about the electrical charges, that is, uh, pila ka ba nito nga? 30? Okay. So we keep on repeating about the electric charge. So what is the function of the electric charge? Okay. So we have a guide question here. How do electric charges interact? So of course, the electrical charges interacts depending on the kwan, the charges. For example, if it's negative or positive. So it's very important for us to at least know, to get, okay, or to know what is the charges of the given values. Like for example, dili na to maingon nga ma-solve na to ang possible answer niya without realizing that those charges are either in the opposite charge. So we keep on kind of talking about how we can combine, or how the different, or the opposite charges are interacting with each other. Okay, so they interact when they have different charges. So for example, if we have an electric force, a Q1 for example, and a Q2, the force here will be will be the result of the two combining. Okay, it's the same thing as well when it comes to the gravitational force. Okay, this is the reason why we need to discuss about the Coulomb's law. All ordinary matters contains both the positive and negative charge. Okay, you do not usually notice the charge because most matter contains the exact same number of positive and negative charges. An object is electrically neutral when it has equal amounts of both type of charges. Like for example, uh, sa atom, di ba? If we have this electron, the charge of electron should always be equal to the charge of the protons. Diba? Aware mo that, class? And then if we combine both numbers or values of those two charges, may mo siya neutral. Okay? What will be the neutral answer of those two? Diba zero ba ang charge mo sa neutral pag sa mag-uban sila kung si protons?
Yes, sir.
Okay. Because either the neutron there can either release a charge the same as the negative or the same as the positive. No, but the charges will always be the same. So the neutral answer, the neutral amount will be on the zero. Okay? Pero dili siya undefined, no? Zero din siya. So this is how we uh, define the, the neutral, no? Zero. Now, objects can lose or gain electric charges. The net charge is also sometimes called the excess charge because a charged object has an excess of either positive or negative charges. So which it's either the no, either the positive will have the excess number of charge or amount, or it's the positive one. Okay, and sometimes when you have this excess amount of charges between the negative and the positive, the most number of charges, for example, the most number of positive or negative particles present in a specific charges, muna siya ang dominant na memo answer. If the proton is greater than the electrons, then the answer, so the obvious answer there is that you will have a positive one. But if more than a negative than the positive, then the answer will always be the negative one. So, okay, we have the static electricity. We have discussed that one last time. It's the stored energy, the stored electrical charges on a specific object, and then you as a person acquired uh, another charge that is opposite or repulsive to the one, to the specific material that has a charge already. So electric charge is a property of a tiny particles in the atoms. The unit of electric charge is the Coulomb. Okay, so we have the Coulomb. Quantity of a charge should always be identified with a positive or negative sign. So this is how we give uh, a definition to the Coulomb's law. So as you've noticed, no, since we kept on talking about how the charges of the negative and positive is the same. So this is it. Okay. So take note, no, the mass, okay, or the kilogram of each particles is not affected by the charge. Okay? It is not affected by the charge because either the electrons of the proton has a greater or let's say a lesser mass. It doesn't matter because the reaction will always occur in the charges. Okay? It's not about the mass. It's about how the function of the charges. Okay, let's move on to this one because you know it already. How about the electric forces? So we have electric forces and we have gravitational forces because sometimes we have, the word sa dyan kang ninyo, natin phases of matter which is called the plasma. And the plasma contains a different kind of ions. And those ions we're talking about is the positive and negative ions. It's the same thing when it comes to charges. If the universe is composed of these charges, it means that the gravitational forces as well do have these charges, or at least no, it does not compromise the idea of the electric forces, which is kinda relevant because of gravitational forces. Good. So to generalize the idea about the function of those charges, either it's electrical or gravitational, is that kung walay charges present, there will be no reaction, there will be no, let's say, changes that will occur. Everything will be neutral. Okay? So if everything is neutral, then everything will be what? May mo siya undefined. Okay? What's the point of kinda calculating that one? What's the point of looking for an answer? What's the point of calculating? No? So electric forces are created between all electric charges. Okay, by the name itself, electric, because there are two kinds of charges, the positive and negative, and those forces can either react in a repulsive or in a attractive manner. So it's the same thing when it comes to magnetic, no? Either it's an electromagnetic or a magnetic lamp. Those so magnetic we call it poles. Okay, we have poles. We have a negative pole and a positive pole. Okay, so this is how the reaction occurs when it comes to the forces. Now let's talk about Coulomb's law. How do we define Coulomb's law in a mathematical manner? So we have this one. So Coulomb's law relates the force between two single charges separated by the distance. So we have force is equals to the k here is the constant value for the column. So we will know it later. And the Q1 and Q2 is the present of the charges in the specific situation. And it is divided by the radius or the distance in square. So since we're talking about the radius or the distance squared, so we're actually talking about in meter. The charges will be on the coin. Okay. The F here is force, which is the Newton. The K is the constant. The R2 here is the distance or the meter. And then the charges is the capital C, okay, for the column. These are the charges. So the constant value for the K is the 9 times 10 to the power of 9 Newton meter squared per second per column squared. So as you've noticed, no, if we will be removing the unit of the distance and the charges, then basically the constant for the value and the constant unit for this value is a very helpful one as well, because canceling the meter squared and the charges or the column squared will give us the unit of force in Newton. So this is how we interpret the Coulomb's law in a mathematical manner. Okay, more about Coulomb's law. Okay, the force between two charges gets stronger as the charges move closer together. The force also gets stronger if the amount of charge becomes larger. So if we have this, you know, statement, how can we possibly gonna this one interpret? Is it directly or inversely proportional? Are the charges inversely proportional to the force, or they are directly proportional to the force? Anyone has an idea about this statement? Okay, Cyron, Cyron J. How do you pronounce it? Cyron or Tyrone? Acero, are you there, Acero? Acero. Okay, sige. Ikaw, Jade, Lunoy. How about you, Lunoy? How do you interpret the statement, Lunoy? Was the statement all about the charges are directly proportional to the force, or they are inversely proportional to each other? Left na. Are you there, Jade? Lunoy?
Yes, sir.
Okay, okay, what's just your opinion lang, okay? How will you interpret the statement of the Coulomb's law? Okay? The force between two charges gets stronger as the charges move closer together. And the force also gets stronger if the amount of charge becomes larger. So I want you to interpret the statement. Was it inversely proportional or directly proportional? Was the force inversely proportional to the charges or inversely proportional or directly proportional? Directly or inverse?
Directly, sir.
Okay. It's directly proportional actually. Why? Because as the force, again, as the charges get stronger, it means that if the charges are near the if the charges are more closer to the force, it means that they are directly proportional as well. Because if the force also gets stronger, it's the same thing about the charges. So it means that if the charges has a very large amount, no, if those charges has a very large amount, it means that it will affect the force as well because maka benefit ang force dito sa kwan because the force is very dependent to the charges. So the more charges you have, the greater the charges, the stronger the force. Okay, the lesser the charges, the lesser the force. No, so the force between two charges is directed along the line connecting their centers. So they're directly proportional. Electric forces always occur in pairs according to Newton's third law, like all forces. So sa itong kung gani, third law ni Newton,
Law of interaction, sir.
okay, it's about law interactions. Okay, it's the action reaction. It means that every reaction occurs with electric charges will affect the force. That's the reason why they're always directly proportional. So this is how we illustrate the statements. So the force gets stronger when they are moving closer, and the charge also gets stronger, or the force is also stronger when they are moving away. Okay, regardless mo good if they are reacting to the repulsion, the reaction, as long as those charges have a very large amount, then the force also has a very large result. Okay, the force will always be affected by the charges. Okay, that's the statement. So the force between charges is directly proportional to the magnitude or the amount of each charge. Okay, so this is how we interpret the statement. See, doubling one charge doubles the force. So again, the massive the force, okay, the massive the amount of electrical charges is. So doubling both charges quadruples the force. So ano, uh, mathematically in a mathematical manner, no? So if we double the force, it means that those charges are also has a greater amount. Another definition about Coulomb's law. The force between charges is inversely proportional. Remember, they're only inversely proportional to the square of the distance between them. So they are only affected by the distance. Okay. Now, what is the connection of the distance between the force and the charges? Okay. Double the distances reduces the force. It means that the farther the charges, the lesser the force will be made. Okay. So if we have okay, that's the reason why in the formula and the columns law we are doubling sometimes the quiet. We are doubling actually we are doubling the distance because we wanted to see if the connection of those charges, if we will be doubling the charges as well and doubling the quiet and doubling the distance will not affect the whole process of calculating the force. Okay. Now decreasing the force to one fourth its original. So if we will be doubling the distance, for example, no, if we will be reducing the force by a factor of 2, so we have 4. It means that we are decreasing the force to one fourth to its original value. So like this one. Okay. So if we will not be doubling the distance, if we will be uh, sticking to the distance lang, okay, without uh, doubling the value of the distance, we will have the reaction or the relationship between charges nga murag okay lang. Okay? We will be focusing the idea here through the amount of charge and then the force. But if we will be, you know, doubling the factor, okay, by doubling the distance, you will see here in the illustration that it's affecting the the result of the force and also the function of the two charges. So even if the charges have a very massive amount of charge, but the force that will be made will be affected by the distance. Okay, it's the same thing bitaw when we do the repulsion between two magnets. Okay, You will not get the result if we have the same what? If we have the same charges in the both end of those magnets, okay? There will be no attraction. There will be no force that will be made. So what will happen? Dahil that too, either of those magnets will not have a better result, okay? Because they will be affected by the distance. So what force can we get? Okay? There will be no work done there. So there will be no third law of Newton. Okay? There will be no action reaction unless we have this opposite charges. There will be reaction. There will be a reaction and there will be an action because those charges will now function as one. The one will become a potential energy and the other one will become a kinetic energy. So imagine that aspect, you know, on those opposite charges. So that is how the electric charges uh, are defined. This relationship is called an inverse square law because force and distance follow an inverse square relationship. So on the mathematical aspect, we also have this type of problem. Okay? Like when we do have the racial proportion, it's always be affected by the fraction. Okay, so yeah, so that is how we define columns. Question about potential difference and the columns law. Question, reaction,
None, sir, none.
none. Okay,
Wala,
this
sir.
this Thursday, di ba naman sa school?
Yes, sir.
Okay,
Yes, sir.
I will be siguro. Next meeting na lang siguro. How about na lang, yan, how about na lang class if we will be changing the subject na lang ka class para every time man mo face to face bitaw sa Thursday sa inyo ha capstone is maka-assessment na punta na sa ato ang physics. Because siya na magutong mag-solve na in a actual base no good kanang nadyo tayo board kaysa masikog pakita sa inyo og kwan. How about we change the schedule sa 3 eyes ninyo og sa inyo ang kwan physics? What do you think?
Pwede gyapon,
Pwede ra,
sir.
sir.
No,
Pwede rin, sir.
atong
Pwede ra, sir.
i-Thursday atong physics and then atong Monday Monday, Wednesday, Friday atong 3 eyes. Next week, no? Para pag naamoy yung face to face ba, naputi face to face pud nga problem solving. Isa ingani bitaw nga we'll be having a hard time, okay? Because we have no kaya we wanted to answer the examples but yet we don't have a time at all. So why not change the schedule? So we'll have the physics na lang siguro on the Tuesday and Thursday and then the ice on Wednesday and Friday. Okay lang?
Yes,
Okay,
sir.
sir. Okay, sir.
Yes, sir.
Okay, so since majority of you class agreed, so let's change the schedule na lang. And on Thursday, since ato pa man na siya 3 eyes no this week, so na-announce pa na ako yesterday sa inyo about bringing your output from your practical research too.
Wala, sir.
Wala. Can you bring your output sa practical research too? The chapter 1 to 3 that you have made because I will be quiet. We will be using that one for our class tomorrow. Since face to face man no. So we'll have it face to face siguro tugtog siguro atong 3 eyes as well.
Soft copy lang, sir.
No, it's a hard copy because I will
Okay.
be quiet. Na ako'y kanang basta it's a surprise. Okay. So no question. So again next meeting we'll have examples siguro no, from the circuits to the columns para mas masabta na to. Not just the definition but also the function. Okay. Thank you everyone for listening. I hope you have learned a little about our discussion. So you may now leave the class. You may now proceed to your next part, next class or next subject.
Thank you,
Thank you,
sir.
sir.
Thank you. Thank you.
Bye,
Thank
sir.
you, sir.
Bye.
Bye, sir.
Goodbye everyone.
Bye,
Thank you.
sir. Thank you.
Bye. Goodbye.